Okay, great. So you can make words go across the screen. But what's the big deal? What's the big deal? Without rotation, there's no day and night. Without our revolution in orbit around the sun, no seasonal differences on our planet. Without the moon's orbit around us, we wouldn't have tides and our weather would be totally different. Without the axis and our tilt on that axis, we wouldn't even be able to have life on our planet. You and I wouldn't even exist. Whoa. Okay, slow down. Deep breaths. It's okay. Sorry, it's just these are really important words. Okay, now I see why they're so important. Could you maybe start over? Okay, sure. All right, from the beginning. Here we go. So you know how a person can spin a basketball on their finger and it's spinning the whole time, but it basically stays in place? That's because as the Earth is spinning, it's also revolving around the planet, right? And when it's spinning on an axis. And the axis is an invisible line that goes from the North Pole to the South Pole. And the reason the axis is important is because the axis is tilted, right? And our tilt is the only reason that we have seasons on our planet. Hi. Okay, so we're going to talk about rotation and axis kind of at the same time, right? And that's because the planet rotates all the time. And remember that rotation is like another word for spinning. So the Earth is always spinning on its axis, right? But you're going, axis? I don't see an axis. And guess what? If you were out in space looking back at our planet, you wouldn't see an axis, okay? The axis is an imaginary line that we made up to make it easier for us to understand our place in the solar system, okay? So to make it easier for you, here's our planet, and I'm going to make an axis that you can actually see, okay? So the Earth's axis goes through the poles from the North Pole to the South Pole, right? And so now what I have here is like Earth's axis, right? And it's still going to be rotating on its axis. And this first thing I want you to notice is that as it's spinning, and I'm going to put this over here with the sunshine. Here's our sunshine. As it's spinning, half of it is exposed to sunlight while the other half isn't, okay? And it takes us 23 hours, 56 minutes, and 4.1 seconds to spin all the way around one time on our axis. But could you imagine if that was how we measured a day? We would say 23 hours, 56 minutes, 4.1 seconds. That's a lot. A solar day is the length of time it takes the planet to rotate until it reaches the point where the sun is at the exact same point in the sky, and that is 24 hours. So that's why we use our solar day. 24 hours is a lot easier to use. The next part you need to know about is the tilt. The Earth is not perpendicular compared to the sun. In fact, it's tilted at about 23.5 degrees, a little bit like this, right? 23.5 degrees may not seem like a lot, but that tilt is what allows us to have life on our planet, and here's why. So there's another imaginary line on our planet, and that line is the equator. The equator splits our planet into two halves, a top and a bottom. The top part is the half of the planet above the equator, and we call that the northern hemisphere. The bottom part, or the part below the equator, is known as the southern hemisphere. Now this picture shows the Earth without the tilt, but remember that the tilt is very important. Now let's move on to the next picture. This picture shows the Earth with a correct tilt on its axis, which you may recall is 23.5 degrees. The Earth is at a point in its revolution where the northern hemisphere is tilted away from the sun and the southern hemisphere tilted toward the sun. The northern hemisphere is receiving the least amount of sunlight, so it's experiencing winter, while the southern hemisphere is getting the most direct sunlight and is experiencing summer. Okay, so let's look at this another way. The Earth is always revolving around the sun. It's following its orbit, or the path it takes around the sun. As it's revolving, that tilt never changes. it stays 23.5 degrees pointed toward the North Star. Now, because of that, as it's revolving around the sun, different parts of the planet get more direct sunlight than other parts of the planet do. And because of that tilt, the seasons are actually opposite the northern hemisphere to the southern hemisphere. So let's start over here. Over here, we have summer in the northern hemisphere because that sun's light is reaching the upper portion of our planet. And when it's the most direct sunlight we're going to get, it's going to be summertime. The southern hemisphere is experiencing winter because the sun's light is the least direct it's going to be. Now, as we continue on our revolution, then when we get about halfway through, then there is less sunlight on the northern hemisphere and it's increasing in the southern hemisphere. So we're experiencing autumn or fall because we're starting to have less hours of sunlight per day. But this southern hemisphere, because it's the opposite of us, is increasing the amount of sunlight they get per day, so they are experiencing springtime. As we continue on, we are starting to tilt away from the sun. So while we're still receiving sunlight, it's the least direct we're going to experience all year long. And so because of that, we get less heat and we experience the season of winter. Of course, the southern hemisphere is the opposite, and now that it is tilted toward the sun, they are experiencing summertime. As we continue through our orbit, we get back over here to where we are experiencing more sunlight, and we have the season of spring. And then during spring, of course, the southern hemisphere is experiencing autumn. And as we finish up our revolution, we end up back again at summertime. Okay, so once again, the amount of sunlight on the northern hemisphere is always the opposite of what the southern hemisphere is getting. Right? And when we get the most direct sunlight, it's summer. The least direct sunlight is winter. And of course, in between, we have autumn and spring. Right? And so because of our revolution around the sun and the tilt on our axis, the Earth experiences different amounts of sunshine and therefore different seasons. So, just to review, 24 hours is one rotation or one day on our planet. The rotation is the reason we experience day and night. While the Earth is rotating, it is also revolving around the sun at the same time. The Earth's revolution takes 365.26 days, which is 1 year on our planet. The path or revolution that a planet takes as it revolves around the sun is also known as its orbit. The Earth is not perpendicular in relation to the sun. It's actually slightly tilted. The tilt of our planet is the reason that we experience different amounts of sunlight and therefore different seasons on our planet. The seasons in the northern and southern hemispheres are opposite one another. This is because the tilt of our axis causes one hemisphere to be hit more directly with the sun's rays at any point during our revolution. The sun's rays hit our planet most directly at the equator and spread out to hit the poles the least directly. That allows for some heat throughout the entire planet. Without the tilt, it would be too hot on the equator and too cold everywhere else for the Earth to support life.